Hello, welcome to another video by VOX Guitar Amplifier Repairs. Stuart Smith in the workshop as ever, and today we have a VOX AC15C1. Relatively new, I think less than 10 years old, this amp, and it's completely dead in that there's no output. The power light comes on, not a peep out of the speaker. So this could be something fairly straightforward. I can't recall whether this amp has an HT fuse inside. There isn't one on the outside. My obvious port of call would be the HT fuse is blown, but it might be something a little bit more difficult, so let's get the back off and have a look inside, and hopefully we can make short work of this, but you never know when you start on an amplifier what you're going to find. One of the annoying things about these VOX amps is the number of screws you have to take out to get the back off. There are some missing on here. The customer said his dad had had a go at the amp and lost some of the screws. Anyway, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, just 16 screws to take out to get the back off the amp. Right, that's all the screws out, and now the back can come off. There we go. And the good thing about these amps is that everything is fairly accessible on the inside. So let's have a little look inside. Well, the first thing I notice is we have two fuses here, so we'll be checking those. And then we have the standard printed circuit board construction, really. Loads of op amps too. All looks very clean though. I mean, this is almost brand new, this amp, so I wouldn't expect anything to be much wrong with it. And this amp takes a couple of EL84s and 3 ECC83s. Fairly standard, like the Fender Blues Junior and so on. Right, well, I think the first thing to do is check those fuses, and then we can go from there. Okay, here we go. I'm using my Hioki fancy meter here, just because I've left my other one in my car, to be honest with you. So here's fuse 1, that's okay, 1 ohm. Here's fuse 2, also okay, that's a bit of a shame, half an ohm, so it's not such a simple job as an HT fuse has blown. Okay, so well, what I haven't done is to turn the thing on and actually confirm what the customer says. So let's do that next. Let's get the thing powered up and see what's happening. Okay, the power light comes on okay. Now we'll try to stand by. Literally nothing, not even the slightest pop of anything there. So valves are lit, I can see quite clearly, they're all working. Ah, okay, I've spotted a problem immediately. Right, I'll get the camera out and show you this. I didn't notice it in my first sweep past the board because I was just concentrating on camera work, but you can see quite clearly, look, that this resistor here, R76, is completely burned out. Not sure what value that is or what it's doing. My guess is going to be the same as that one. Where are we? That one there, look, R83. My guess is that those two are, you know, doing the same thing. Maybe not, I'll check that. So I probably need to check the schematic now and see if I can find out what that R76 is doing and what value it is. Okay, the good news is I had the right schematic, and both R76 and R83 are 470 ohm screen resistors, I've just measured that one and it's okay, so I'm going to change that one. I'm also going to change the power valves because I'm wondering why the screen resistors have gone, and I think those valves have been in since the amp was new, so I'll, just as a precaution, I'm going to put a pair of EL84s in there. First of all though, let's change that resistor. Okay, I've removed the resistor there by just chopping it out, and there's the offending article, well cooked as you can see. The repair's not so easy because to get this board out we have to get to these tiny screws at the back here, and you can't get a screwdriver in due to the height of this here, so I don't even know how they put this board in, let alone get it out. I've got to get to that screw there and the one back there. Pretty impossible really, so I'm going to have to do a top side repair. It'll be perfectly okay. This resistor here, that side of it goes to pin 9, which is the screen of the valve there, so that's where we're going to pick up one contact for the new resistor. They haven't made it easy for the other contact because that's here, and I could solder onto that wire, but I think I'm going to scrape back a bit of the board here to get access to that quite thick track there, and solder onto that track with one side of the resistor and there with the other side of the resistor, and that'll be perfectly okay. Then we'll take the valves out and power it up. So you can see there I've scraped back a bit of the board just using the screwdriver actually, and then I'm just going to now solder a pad on there, so that's the next thing to do. Okay, there you go, you can see I've made a little solder pad on there. So now we can solder the resistor between that pad and the pin top left of there. So we're going to get the resistor in there, something like that. So I just need to bend the leads of the resistor to suit and then solder it in. Something like that should do the trick as a first pass. And there you go, a perfectly adequate top side repair. Now if you're a purist watching this and feel that I should have changed that resistor properly by taking the board out, please remember this is also all about money and not just about purism. I'll be charging the customer about £30 or £40 for this repair, and he'll be delighted with that, plus the valves of course. But if I were to take this board out, I could easily get involved in another couple of hours work, so another £75 on top of the bill. So in other words, you know, £125 versus £105 versus £35. You know, there's a very big difference between those two amounts. So this repair is perfectly satisfactory. It'll last forever, and let's not get too precious about you know, taking the board out. On the left we have the valves that were taken out, fairly cheap Chinese valves, almost certainly original to the amplifier, so no harm in changing those, and we're going to pop a couple of JJs in. Then we can power up and hopefully it'll spring to life. Let's see. Okay, moment of truth. You're seeing this as I'm seeing it. I haven't turned it on yet. A couple of new JJs in. We've replaced that resistor and I've put this blue lead back on, which I nearly forgot. We'll power it on. Mains in first of all would be useful. Here we go, mains in. Power's on. Out of standby. Suspiciously quiet. Very quiet. Let's see if we've got any signal there. Nothing. Oh, that's surprising. Standby on, that's all okay. The resistor's fine, that's not burning up again or anything. Huh. It's absolutely dead, there's not a peep out of this. just put an external speaker in. Nothing. That's a bit of a surprise. No, I would have thought that would have sorted that. Yeah, shame. We're going to have to get technical with it now. Not missing anything, am I? Just have a think a second here. Valves are on and warm. Right, we're going to have to start measuring some voltages and see what we've got around the place. I'm quite surprised at that. Thought that would all come to life. Right, let's see what we've got on the anodes of these valves. Well, we've got HT, look. That's okay. There's some screen voltage there, look, 466, and it should be the same on this one. It is, so our screen resistors are working. Okay, I'm going to check what they do on the cathode of this amplifier. I can't remember how this works, whether it's got a cathode resistor or what happens to the cathode, because obviously if the cathode's open circuit we won't get anything going through the valve. So I'm just going to have another quick check of the schematic. Okay, I've printed off the relevant part of the schematic for you. I thought you might find it interesting. Here are our two EL84s. Here are the screen resistors, one of which have gone open circuit. So we have 470 ohms there and 470 ohms there. And it's what's called a cathode biased amplifier. I thought it was, I just couldn't remember. So that both cathodes are connected together. A bit of a complicated old rigmarole this, but forget about that. Both cathodes are connected together, and they both go via R79, 120 ohms, 5 watts to ground. And the AC is bypassed by this C54 here. So I'm hoping what's happened is that the grid resistor's gone, sorry, the screen resistor's gone. One of these valves has drawn a heck of a lot of current. It's all flowed down here and it's cooked this 120 ohm resistor. I'm hoping that's open circuit. That capacitor will be fine. If that's open circuit, we need to replace it, and this will spring to life now, this amplifier. So let's see if we can find R79, 120 ohms, 5 watts. I didn't spot a 5 watt resistor, I have to say, when I was looking around the place. So where is that? Can't see anything remotely like a 5 watt resistor here actually. Okay, took a bit of finding that. It's here, look, R79, between there and there. And it's on the other side of this board here. So again, to get that board out is a little bit easier, but again I think we can probably just do a top side repair there and put a resistor across there. I've measured that and it is open circuit, so our cathode resistor is gone. There's our cathode bypass capacitor there. Bit of a funny way of doing it, this. I mean, you know, here are the power valves. You really want these resistors up, you know, next to the power valves, not going up through this multi-way connector up to another connector there and then into here. Very bad design, that. Anyway, there you go. So I'm going to attempt to put a resistor across here and see how we get on. I'm having second thoughts about doing this from the top side, just because they're power resistors and they can flap around a little bit. So I think I'm going to have a go at taking this board out. It's much easier than this one because you can't get to the screws on this board. So I'm going to take these screws out here I think there are 4 of them, take all the controls off and the nuts, and hopefully I'm going to be able to just get this board down enough and out. You see most of the cables are on the underside, look, allowing it to hinge this way, and I'm hoping I'm going to be able to get to that resistor without a massive drama. Anyway, that's the plan. Let's give that a go. First thing is to get the knobs off. I just get in there with a screwdriver and lever it up. This has got some insulation on it, this screwdriver, so it won't scratch the case. I've done this thousands of times, so there's absolutely no danger of me damaging the case doing this. So, and last one. There we go. Now the next thing is to take all these nuts off. Again, I use this little adjustable wrench. I have people shout at me for doing this, but I can promise you I do not mark them for fascia and never have. So I give them a little half turn like this, just to loosen them. One good thing about this is once this is all off, we can clean up this front panel here, which is quite dirty. And that's quite hard to do when the knobs are on. Okay, that's all those loose. I usually get a separate pot here and put all the nuts and washers in there. They get like this. I mean, they spend all their life upright like this, collecting dirt and crap. Right, that's that. So all those are loose. Right, now I'm just going to remove those 4 screws. One. I think it's just this one over here. I think there's only 3 screws holding this in. There we go. That's good. I tell you what I want to do before I do anything. I just want to check that this amp is discharged. I'll tell you why. Because with no current going through the cathode there's not an easy path to discharge the caps. There's 280 volts on pin 3 there. Okay, well I'm glad I checked that. I would have got myself a nasty little shock there if I hadn't checked that. Right, I'm just going to discharge that and we'll be good to go. Right, I just discharged that with a crop to crop lead because there's not really much current there, and we've got 3 volts on there now. Good. Always best to check these things. Get a nasty shock from that, even though it's disconnected. So yeah, with the valves on, you see, when you turn the amp off, the valves are still warm, so they drain all the current down, and normally you don't need to discharge. But because our resistor is open circuit here, we don't have that. Let's see if this board is going to play with us and come out nicely or not. Looking promising. Oh, look at that, that's amazing. And look, there are our culprits there. So we've got, that's 120 ohms at 5 watts there. Right, so we need to remove that and replace it. Right, I didn't show you that because I had my head right in the way, but I was able to get the soldering iron up underneath there and then just lever the resistor out one side at a time. That came out actually fairly straightforwardly. So just to prove that we aren't being silly, let's double check that it's... Oh, bugger. Would you please... That's ridiculous. Oh, that's actually okay. I measured that. Oh! I measured that in circuit and it was open circuit. Huh. Damn. Well, I don't mind telling you, I'm a bit fed up about that. You know, I actually measured that in circuit and it was open circuit, so whether I didn't quite get the the meter connectors on there or something, I don't know. Just taking the opportunity whilst it's all out to clean this up, which doesn't take long with all the controls off. So now I'm at a bit of a loss about what's going on here. Right, well, measuring around the base of this valve, we have got on the anode pin 7, 450 volts. On the screen, 450. On the screen, oh no, we haven't got any screen voltage there. Okay. Right, okay, I was misreading that then. It's funny, isn't it? I haven't got my normal meter with me. I've left it in the car and someone's borrowed my car. So I'm using a different meter. I'm using this Hioki one and I'm just not used to it. It's a very sensitive meter and I've been misreading the screen voltage here as 450 volts, actually 450 millivolts, which was a ridiculous coincidence, but there you go. So what I thought was 460 screen volts is 450 millivolts on the screen. So in other words, we haven't got a screen voltage on either of these. Okay, well that kind of makes sense now. Right, so let's go back to the schematic. I will go and print off a bit more of the schematic for you, but I'm suspecting that the resistor that supplies the screen voltage, which these two resistors go to up there, has gone open circuit. So I'm going to turn the amp off. Need to remind myself to discharge it. I'm just going to have another look at the schematic to find out how that screen voltage is derived. I've been chasing my tail a bit this morning. That happens sometimes. I'm going to leave all this in because I want you to... I know a lot of people really enjoy seeing proper amp repair exactly as it is on the bench and all the frustrations and red herrings and false starts, rather than just go in and repair it, you know, making yourself look like Superman. So I'll be back in a moment. Alright, continuing with the investigation. The screen voltage is derived via this R81K5 from the HT. So my guess now, as I'm running out of guesses, is that this R80 might be open circuit. Now that was the other one. I remember seeing it, funnily enough, and wondering what that power resistor was. That's the one on the other side of the one we took out, this here, R80. So I'm going to discharge this and then get a meter on there and see if I can measure anything there. See if that's a 1K resistor. Goody, we're making a little bit of progress. R80 is indeed, in theory, open circuit. I say in theory because I measured R79 and thought it was open circuit. So I'm just going to, and that would make sense. So basically the valves drew too much screen current and it popped the screen supply resistor, and I was fooling myself a bit by measuring what I thought was 450 volts screen and it was 450 millivolts. So let's take the board out again, which we're now experts at doing. There we go. And it's R80, which is this one here. So we will take that out in the same way I took the other one out, which wasn't again particularly easy. But I'll do that, and to do that I need to get my head in the way, so I'll just turn the camera off. Right, there's the offending item, and I'll just measure it, and I'm hoping it's going to be open circuit. Yep, open circuit, look. 30 meg, that's just me holding the connections, so that we have an open circuit screen supply resistor. Thank goodness! We are now actually able to make some progress, because replacing that will, he says with confidence, fix the amp. Let's see if I've got one in stock. I'm just going to clean up the holes on that resistor using this chem wick, solder wick. It's a good way of getting the solder out of the holes so that I can just pop in this this new one. So I'll just do that now. Right, here we go again. I've got the resistor back in, and I've got the board back in with just one nut on the pots, and I think I'll just pop this screw back here. I think this acts as an earthing point. It may not be necessary, but we'll just bung that one in. And yeah, moment of truth again. Let's try powering it up once more. A bit more hopeful this time. Power on. HT. Oh yeah. Yep, I can hear the tremolo going. Fantastic, hooray! I think we've actually fixed it. There we go. That's brilliant. I'm well pleased about that now. Took a bit of a while to get there, but we got there in the end. So screen resistor had taken out the 5 watt 1k resistor which supplies the screen voltages, and I've changed it to power valve 2. No idea why it went. May have been a faulty power valve. Would have been a bit hard to do this without the schematic. I happen to have the schematic for this because I was struggling to find these power resistors, and they're on the other side of the board, and I would have struggled to find the resistor feeding the screen as well without seeing the schematic and seeing where it was. So that was quite useful. I had the exact schematic for this board. Right, next thing to do is to get all the nuts and knobs and screws back on, give it a final test, and we're good to go. Well, there you go. That's what I call a bread and butter repair. It's very typical of the repairs that I do. Open circuit screen resistor, and it had taken out the screen supply resistor too. Probably those cheap Chinese valves, but we will never know. I put in a pair of JJs. I hope you enjoyed me leaving all the red herrings in and my mistakes. I always think that's quite helpful for people learning how to repair amplifiers. It's not all plain sailing, and you can get taken off down some country lane that you think leads to the main highway, but in fact doesn't. And I was a bit unlucky there, I think. Don't you think that the meter was reading 450 millivolts? What are the chances of that when I was looking for exactly 450 volts? But that's how it is sometimes. Anyway, hope you enjoyed that one. I've got a workshop full of amplifiers at the moment because I've been away on a holiday, so I'm going to plough into the next one, and I'll probably make a video of that too. Thanks as ever for watching, and I'll catch you on the next video.